Good day, this is Dr. Ron McFarland with ISOL531 Access Control, and today's lesson is Lesson 5, Physical Security and Access Control in the Enterprise. And in fact, if you are considering certain certifications like the CISSP, this is an essential part of the exam itself. So look forward to this, and in fact, when I'm doing my cybersecurity readiness assessments for a lot of different manufacturers, one of the aspects is physical security. So it's a key aspect of keeping an information system environment secure, as we well see. Anyway, access control involves perimeter security, building security and access, points of entry and exit, physical obstacles and barriers, access to physical areas within the building. And here's kind of an overview from the book. And in a sense, I've already, in a prior video, talked about American Express. Certainly other organizations have additional security measures to secure the perimeter of the environment as well as internally. Video cameras provide perimeter coverage, and cameras, I would say, are limited because most environments will have cameras in the highly more secure areas. So we'll take a look at that in the textbook. It explains that a bit more. Also, in the classified government facilities are levels 1 through 5. Take a look at those on page 182 in your text. Biometric access controls, things like what you know, a password or passphrase, what you have, a smart card or a token, and what you are, biometric traits. Type of biometric systems include fingerprint scans, retinal scans, iris scans, hand geometry, and the much talked about facial recognition. Some of the implementation issues that we run into are false acceptance rate, and the percentage of imposters that will be recognized as authorized users would be a false acceptance. And false acceptance are often called type 2 errors. Now, regarding other implementation issues, we have the type 1 errors. False rejection rate. The percentage of attempts by legitimate users that are rejected by the system, again, are called false type 1 error rates. Implementation issues continued. The crossover error rate, CER, the point at which type 1 errors and type 2 errors are equal. CER is an accurate way to compare the real accuracy of various biometric systems. The smaller the crossover error rate is, the more accurate it is. And the textbook discusses this in greater detail, so take a look at the CER and how that works into play with both type 1 and type 2. Implementation issues contained failure to enroll rate. That's the percentage of failed attempts to create a sample dataset for an individual divided by the total number of attempts to enroll users. The failure to capture rate is the percentage of failed attempts to authenticate to the system. Modes of operation include both enrollment and identification. Enrollment is the taking readings for an accurate image of the individual's traits. This data is stored for later retrieval. Again, it's like a pre-scan, if you will, of a thumbprint, facial recognition, those sorts of items. Identification is taking a reading and comparing it to the previously stored data on an individual. Biometric system parameters include universality, uniqueness, permanence, collectability, performance, acceptability, and anti-circumvention. Each one of those are explained in greater detail. Let's look at this item right here, access control list and access control entries. We've already talked about ACLs. ACL is made up of ACEs. An ACE contains at least 2 items, a security identifier, SID, and 1 or more authorization levels for each SID. There's some examples in the textbook that you should look at. An SID is created for a user, group, or computer account when a new user account is first created on a network. Some example of ACL permissions include this whole list: delete, read, write, modified, execute, full control, and no access. Access control models. Access control models include discretionary access control, the policies defined by the object owner. Mandatory access control, the policy is defined by the system. Now that's where we talked about classification levels as one example of MAC. Role-based access control, RBAC, which is a predominant way of doing access control. The policy is defined by the functions the user performs within the organization. For example, a user roles can be human resources or finance. Attribute-based access control, ABAC, policy a function of a subject's characteristics, as an example. Again, authentication factors, covered this earlier, something you know, something you have, and something you are. Challenge response, this is used in networking as well as in the information system server area. So challenge response, a request is sent from the host to the AS. The challenge is returned, and then look at number 3, enter a challenge into the token. Number 4 is the response is displayed on the token. Number 5, enter the response. And number 6, the response is sent back to the AS. So that's kind of a chain that depicts the server side. There's also a challenge response mechanism in routing as well. So Kerberos was invented by MIT a few decades ago. It's a network security protocol that provides authentication and authorization services on a network. It's based on 3 systems: the Kerberos Trusted Key Distribution Center, the KDC, the Kerberos Ticket Granting Service, TGS, and the Kerberos Authentication Service. The Kerberos process, a little more specifically, the client requests services from the application server, the ticket granting ticket and the client TGS system responds back. The TGT ticket and authenticator, second slide down, is passed on to the ticket granting server. The client server session key and client server is passed back to the user. There's some potential weaknesses of Kerberos. Brute force attacks. The key storage is an issue. Kerberos tickets are also cached on a user's computer system, which is a vulnerability. Now, clocks must be synchronized to complete authentication. Thereby, timing attacks could occur. Central server continuously availability requirement for host synchronization, and also anytime you are using Kerberos, you have a potential single point of failure. For example, DDoS or DOS. Next, network access control. The use of policies within a network infrastructure that limit access to resources until the system proves that it has complied with the policy. NAC components include routers, switches, servers, and network firewalls. So we'll put these network access control parameters into the system to limit the access to these devices. The OSI model, I always tell my networking class to remember this. If you haven't heard this before, all people seem to need data processing, APSTNDP, from the top down. And that's one good way, mnemonic, if you will, to remember this model. The MAC portion, again, that layer 2, a unique identifier of a network device. When a device is powered up, the MAC address is sent out to the network connection. Layer 3 techniques, access control list, the route maps, and disabling IP routing for complete IP traffic isolation. Again, getting back to layer 2 and layer 3, layer 2 devices are things like switches and hubs, which are rarely used, but I've seen them in certain environments. Layer 3 devices are routers. Wireless, IEEE 802.11. Identification, confidentiality, and authorization are all part and parcel of 802.11. That's spelled out a little bit more in the textbook. Take a look. Single sign-on, we see this in many environments. It's a method of access control that allows a user to log onto a system and gain access to other resources within the network. Again, the risk is you're having one point of login, but then again, if you've ever been in an environment where you had multiple logins to multiple systems, that would drive you crazy as a user. Also, SSO eliminates the need to remember multiple passwords. Also, it ensures that the same password policy is applied to all resources. Also, it reduces the need for an administrator to manage various accounts on individual resources. So those are the benefits. The drawback is one single point of attack or failure. SSO, there's a couple of aspects in the textbook. Look at defining the scope for SSO. Look at configuring user and role-based user access control profiles. Look at common configuration and also enterprise SSO. Best practices include discovery and identification of all data on the network. The development of policies based on risk associated with the data is one thing that needs to be really focused on. The placement of appropriate access controls on data based on risk levels. We already talked about risk levels of data. And continuous monitoring and test policies of access control is a must. And in fact, in an information security plan, if you're going with DFARS, which is Department of Defense, they recommend once a year. If you're using other standards like the CIS standards, they recommend quarterly. And in fact, I would recommend just being in the environment monthly, a monthly analysis of this, or greater. Now, in summary, week 5 has several homework assignments. Certainly read through chapters 9 and 10, tear through a lot of these definitions. This chapter will be part and parcel of the quizzes, of course, and also are essential for the 2 labs assigned with this homework. So I wish you luck, and let me know. Again, Ron McFarland, ISOL 531. Thank you so much for listening. Bye now.